Hello, I'm Stuart Reid. Welcome to this course on AI testing. In this session, I will continue with the introduction to artificial intelligence. Over the next couple of slides, we will see one of the main differences between generating an AI-based system and building a conventional system. First, we look at a simple representation of conventional non-AI development. Initially, requirements are agreed with the customer. From these requirements, the software developer designs and implements the solution in source code using a programming language. This source code is normally compiled into an executable program, which is then deployed onto the target system, in this case, a laptop. Here we'll see that developing a machine learning system is quite different. However, as before, the process starts by understanding and agreeing the requirements with the customer. The data scientist next gathers suitable examples as training data. They then write a machine learning algorithm. Well, actually, they're far more likely to retrieve an algorithm from a software library. Next, the training data is fed to the machine learning algorithm, which uses the training data to create a machine learning model. This automatically generated machine learning model is then compiled into an executable program and deployed to the target system. The important point of difference between the two approaches is that the deployed machine learning model is not built by a developer or a data scientist. It is instead automatically generated by the machine learning algorithm from the training data. Don't worry if it sounds complicated and the machine learning development process is difficult to visualize. This process will be covered in far more depth when we cover machine learning systems a bit later in the course. Data scientists are much the same as the developers of conventional code, inasmuch as both build systems with support from development frameworks. Naturally, the frameworks used by data scientists are specific to AI, and on this slide we can see a selection of popular AI development frameworks. AI development frameworks are often open source, but there are also some commercial frameworks, such as IBM's Watson Studio. It is, of course, always possible to pay for additional support for the open source frameworks. Many of these open source frameworks steer their users to commercial hosting solutions, but the need for this depends on the situation. It's also worth noting that this is not a definitive list and that the available frameworks change over time, as some owners sell their offerings, others go out of business, and new sellers enter the market. However, most of the examples on the slide have been around a long time, in AI terms anyway, and are unlikely to disappear in the near future. Apache MXNet is a deep learning open source framework for deep neural nets that supports multiple programming languages and is scalable to multiple GPUs, and so it will work for large commercial AI-based systems. It is supported by major players such as Amazon, Intel, Baidu and Microsoft. The Microsoft Cognitive Toolkit, CNTK, is an open-source deep learning toolkit. It is cross-platform and supports various operating systems, including Windows and Linux. It supports multi-GPU deployments of neural nets that implement speech, image and text apps. It is used by Microsoft for many of its flagship apps, including Cortana, Bing, Skype, Xbox and HoloLens. IBM Watson Studio provides a commercial suite of tools that support the development of a wide range of AI solutions, such as speech, image and text recognition. Although not open source, it is provided free to students and universities. TensorFlow from Google is a widely used open source machine learning framework, based on data flow graphs for scalable machine learning. It is used by Google for speech recognition in Google Photos, in Gmail, and in Google Search. It is also used by many other large organisations, such as ARM, Airbus, Uber and Twitter. Keras is a high-level open source API written in the Python language, capable of running on top of TensorFlow and CNTK, so providing less technical users with a simpler interface, while still allowing them to produce large commercial quality apps. PyTorch is an open source machine learning library operated by Facebook. It is a scientific computing framework for apps, using image processing and natural language processing. It supports both Python and C++ interfaces, and is used within Facebook, Google and Twitter among others. Scikit-learn is an open source software machine learning library for the Python programming language. It provides various pre-built classification, regression and clustering algorithms. Note that not on this slide is Weka, which is the development framework we will be using for the hands-on machine learning exercises on this course. Weka was developed by the University of Waikato in New Zealand and, despite being free, runs on Windows, OS X and Linux, and has the ability to create industrial and research quality machine learning models.